Hello and welcome to the webinar in the context of the from the sensor into the cloud. In cooperation with Harting, we implemented this procedure based on an example for the injection molding process monitoring. During the injection molding process monitoring, various forms are injected with hot plastic. And each of those forms have implemented a small sensor, which is usually in the range of 0 to 2000 bar. And this sensor, based on the piezoelectronic system, is monitoring the pressure of the injecting process for each form. And according to this, it is possible that you can detect a malfunctioning operation in the tool, and this tool has multiple of those forms, including those sensors. And in this current graphic, you see the devices are involved in this process. So there's this sensor inside the tool, and we have a very sensitive analog signal which needs to be amplified. And the amplified signal then is transformed to a digital signal and then communicated via gateway to the IT infrastructure. And this setup we implemented based on the components we have designed at Perinet. And this setup, what we see here, we have the simulator from the sensor provider, which provides the simulated signal of the pressure sensor based on this line here, and we attach the signal to one of our Perinet components, which are designed for this application directly. And this Perinet component has an analog part where it's getting the analog signal, and it has a digital output where it's communicating the transform analog signal to Ethernet communication medium. And we are especially using here twisted pair Ethernet. The twisted pair Ethernet standard we are complied to is called IEC 63171-6. And the interface we're using to this standard is well defined, and the interface, the face of the connector is basically part of the standard we are complying to. In those communication we have we communicate over this specific medium to a media converter. And this media converter transforms the physical layer of the communication to normal Ethernet, in this case 100 base TX. And here we have a specific gateway which is has the opportunity to communicate to the outside via Wi-Fi or via mobile communication in this case. And we also attached a small edge gateway, the mica, to this setup here, where we actually pre-process also the data that we receive from the injection molding process. So when I press now here this simulator, then we see on the screen the pressure curve, which is rising to 300 bar to this maximum, and then it's falling again. So this is basically a simulation of the process where we see a usual application of this in the field. And usually the implementation to detect whether this is a quality assured product and the product is good enough, there's a defined minimum in a time window. It should not be, the value should not be below this minimum, and usually also not be above some maximum. Yeah, in this process we showed that our component, and in the actual picture what we see now, we see that we have an opportunity that we can directly have intelligence on our nodes or directly in the sensor, which is also a possible implementation here. It is possible that we save a lot of components on the way to the IT technology, and also that our sensors have the capabilities of pre-processing data, because we have the possibility of computing power. So there can be there's a possibility to implement a pre-processing of data, and also to short time saving data. And also we can configure this sensor directly, so that we have the opportunity to have a dedicated calibration directly in this transformation node adapter here. So there is not the necessity that the customer needs to be informed about what is the calibration value now for the specific sensors. So everything can be prepared and it's ready to go in the end. So thank you very much for your attention.